all, welcome to my channel. My name is Tuhin. This is episode 10 and today we'll be building a LangGraph agent and we'll integrate Streamlit along with the LangGraph agent. So we'll have a nice user interface to see how LangGraph agent works, but it will hide the internal complexities. So it is very good way to deploy your application that other users, the end users, can use it through any user interface. Now, what is Streamlit? Now, if you go to the streamlit.io, it'll show you a faster way to build and share data apps. It gives very minimal APIs to create an app very fast. So you just need to import Streamlit as HT, and then you can add few commands and you can create a very good looking user interface which will be integrated with your internal code. Now you can go to the documentations here for the Streamlit for the further explorations. I'm not going into the details for implementing the Streamlit, but it's very intuitive way of making an website or web applications using Streamlit. Now let's go to our application. So I will be using the LangGraph reflection agent that I have shown you in the episode 7 in this series, but I will modify the code little bit in order to put it in a Streamlit callable manner. So for this particular project, I used LangGraph, Streamlit, Python.env, LangChain and LangChain OpenAI. Only additional library that I have used here is the Streamlit. So you can use the Streamlit here. And for dependency management, I used Poetry. So you can check my earlier videos in this series, so how to add the libraries or add the dependencies in a project. First Python file that we need to create is the schema.py, where I have created a class called agent state, which is a type of type dictionary, and I have 5 properties called draft, feedback, final, count and user prompt. So user prompt is the variable where we will be storing initial prompt from the user, and next property is the draft. So after getting the user prompt, it will be sent to the OpenAI to generate that first response, and that will be stored inside the draft. And then in feedback property, what we'll do, based on the certain criteria, we'll evaluate the draft that has been generated by OpenAI, that whether that draft looks good or not. So that evaluation or feedback will be storing it inside the feedback property. Then we have a final property. What if the feedback looks good, then we'll store the draft versions into the final. If the feedback does not look good, we'll continuously iterate through, and we'll see it in the next section. Count we kept to check if it goes for continuous loops for some time. So we'll end the loop and finally put the draft versions into the final and end that. Now let's go to the nodes. We created one function called load model. So what we are doing, we are just loading all the environment variables, and then we used Chat, OpenAI, GPT-4o Mini for this demo purpose, and it is returning the LLM. And then we created the 3 nodes. One is the draft node, another is the reflection node, another is the revise node. So draft node, what it will do is like it will store the initial response from the LLM, okay, and reflect node just evaluate the response from the LLM, and based on certain criteria, that prompt you can see it here, and if it looks good, then it will respond to it looks good. If it requires the another set of iterations, then it will give the proper feedback. Okay. Now that feedback will be stored inside the feedback property. Now going to the revise node. So based on the given feedback, it will modify the draft and it will just generate another revised versions of the output. Now this is revise node. And now we have another function called feedback condition. This is just for creating the conditional edge or feedback loop. So it will check that if it looks good, then it will go to the end. Maximum iterations has been done, then it will go to the end. Otherwise it will go to the revise node and continue and loop through. Now let's go to the graph.py. Now what we are doing, we have created 2 methods here, build graph and get result. In the build graph, we are creating the graph. So in order to create a graph, you need to use this method called graph called state graph, and you need to pass the agent state that we have defined inside schema.py. And then we need to add all the nodes, that is the draft, reflect and revise node that we have already defined inside nodes.py. Now inside graphs.add edge, we will add the edges between start and draft, and in the graph add edge, the draft and reflect node will be adding. Now here is the conditional edge we will be creating. So this is the start node, source node, and based on the feedback conditions that we defined inside node.py, it will go to the, if it is a revise, then it will go to the revise node here, and if it is the end, it will go to the end node based on the feedback condition. Now in the finally we are creating the loop here, that is the graph add edge, the revise and reflect, and then we are compiling the graph and returning the reflection. For getting the result, we will just take the final result here, and we'll show the final property from the result. So because the result contains the entire agent state, and we are getting only the final property here. Now, so instead of main.py, I created app.py. Here we will be having very small Streamlit related functions. So Streamlit is very minimalist. So you can use very small set of code, but for writing a very nice looking application. So for creating a title, we create ht.title, and then we are taking the prompt from the user. That is, for that we created an input, that chat.input, and it will ask you say something, and then we are calling that build graph, and we are storing it in app. Then finally we are calling the get result that I have defined inside graph.py, and we are passing the app and prompt, and we are finally getting the result. And when you get the results, we are writing in a Streamlit again, and it will also write what was the initial user prompt was given. So intermediate steps that will done inside the code, that will be hidden from the user. So that will be entirely happen internally, and it will give you the final version after all the iterations has been done. Now let's run. So in order to run a Streamlit applications, you need to do Streamlit run app.py. So you see it looks like this, and it calls SLWriter agent, and it asks say something, and we'll use the same some prompt that is supposed to be given by the users, that is India's landing on moon. Now it's running, you can see it here, it's running, and after certain iterations it will give you the final output. You can see it here, that is user prompt is India's landing on moon, that was given by me, and it is a revised version. So India's Chandrayaan-3 successfully landed on moon, and making India the 4th country to achieve the soft landing on the lunar surface. So this is the final output, but inside the code you can see it here that there's the multiple iterations has been performed. So feedback, then iteration 1, revised draft, then what is the feedback that was given by our reflection agent, what is the initial draft versions that has been generated, and final version what is generated. This is the revised final versions, and these revised final versions we are ultimately seeing it in the agent. So you can build very complex applications, and there is one more important thing here, that you can deploy that application as well. Now if you go to the terminal here, you can see there is a network URL that has already been published. So using the network URL, you can access that particular application from any other system as well. So it will consider your system as a server. They can use this URL to access that application. So if you want to share your demo to others, then it's a very good way to create one nice looking application and then finally share it with. This is the end of a LangGraph series, and if you have liked my video, please don't forget to like, comment, share and subscribe. Thank you so much for watching.